Hi guys, today we are going to be covering integration by parts. Let's take a look at the first example and try to solve the indefinite integral of x ln x. The integral of u dv equals to uv minus the integral of v du. The main objective is to identify u and dv and assign it for either x or ln x. When we differentiate u, we will get du. When we integrate dv, we will get v, which are the terms on the right hand side of the equation. Now let's investigate x ln x. If we let u equals to x, the derivative of x is 1. And if we let u equals to ln x, the derivative is 1 over x. If we let dv equals to x, the integral of x dx is half x squared. And if we let dv equals to ln x, well, we have to use integration by parts just to solve that, so that's quite troublesome. Therefore, we're going to choose x to be dv and ln x to be u. Looking at the right side of the equation, we have u, which is ln x, we have v, which is half x squared, and we have du, which is 1 over x dx. Now, let's substitute this and perform integration by parts. We can simplify the second term by bringing the constant outside and simplifying x squared times 1 over x. This leaves us with half integral of x dx. Solving this will give us our final answer. For the second example, let's take a look at x squared and cos x. Which one do we assign for u and which one do we assign for dv? If we let u equals to x squared, the derivative of x squared is 2x. And if you let u equals to cos x, the derivative of cos x is negative sin x. If you let dv equals to x squared, the integral of x squared is 1/3 x cubed. And if you let dv equals to cos x, the integral of cos x is sin x. Since it is more neater to differentiate x squared and integrate cosine x, we will use those. Also, we want to avoid doing integration by parts by having negative signs, fractions, and higher powers. So let's go ahead and differentiate the left side and integrate the right side. Taking a look at the right side of the equation, we have our u, which is x squared, we have our v terms, which is sin x, and our du, which is 2x dx. Just like before, let's substitute these terms into the equation. At this point, our second term is x sin x dx. Therefore, we have to perform integration by parts one more time by letting u equals to x and dv equals to sin x. As usual, we will differentiate the left side and integrate the right hand side. And finally, we can perform integration by parts by substituting the new terms into uv minus integral of v du. Let's focus inside the bracket. For the first term, uv is negative cos x times x. And for the second term, it is negative integral of negative cos x dx. So negative times negative for the second term becomes a positive. So now what is inside the bracket? It is negative cos x times x plus integral of cos x. The integral of cos x is sin x. So therefore the final answer is x squared sin x positive 2x cos x. And for the second term, it is positive sin x times negative 2. So therefore it becomes negative 2 sin x plus a constant. For the third and final example, let's solve the indefinite integral of e to the power of x times sin 2x. Looking at these two terms, it is not as straightforward as the previous two examples. Looking at the first term, integrating or differentiating e to the power of x will give us e to the power of x. The issue now is the second term. Differentiating sin 2x will give us 2 cos 2x. And integrating sine 2x will give us negative half cos 2x. So as you can see, we want to avoid the fractions. Therefore, we will let u be sine 2x and we will let dv be ex. Now let's go ahead and differentiate the left side and integrate the right side. Let's plug our u, v and du terms into the formula and perform the integration by parts. Similar to example 2, we have to perform integration by parts one more time. So let's go ahead and do that. To avoid the fractions, we are going to let u be cos 2x and dv be e to the power of x dx. We will differentiate the left side and integrate the right hand side. We can perform integration by parts by substituting the new terms into uv minus integral of v du. So now, do we perform integration by parts again? The answer is no. If we have observed the third term on the right hand side of the equation, which is integral of e to the power of x times sine 2x dx, is the same as the left hand side of the equation. Now we can write the equation as such. For simplicity, we will let integral of e to the power of x times sine 2x dx be y. It should be noted that e to the power of x sine 2x, which is the first term on the right hand side of the equation, cannot be termed as y. This is because it does not contain the integral sign. Now let's bring the y to the left side and solve for y. Now let's substitute back y equals to integral of e to the power of x sine 2x dx. And therefore the final answer to this question is integral of e to the power of x sine 2x dx equals to 1/5 times e to the power of x times open parenthesis sine 2x minus 2 cos 2x close parenthesis plus a constant.